Graph the function. All right, so we have g of x is equal to x squared minus x minus 6 over x squared minus 1. All right, so what we want to do is first factor both the numerator and the denominator of the function. So for the numerator, it'll be x, and factors of 6 that subtract to give you 1 are 2 and 3. So let's do 2 and 3. And then, of course, we want the larger to be negative, and we have to have a sign of each because the 6 is negative. All right, in the denominator, we're going to have a difference of 2 squares. That factoring is easy to remember. It's x and x minus 1 and plus 1. Okay, so it's factored. It's already written in lowest terms. We can't cancel anything. So we're going to move on to locating the intercepts. Remember that you will find your x-intercepts by setting the numerator, in this case, equal to 0, right? So in other words, x plus 2 is equal to 0, and x minus 3 is equal to 0. You end up with x is equal to negative 2, and that x is equal to 3. So at negative 2 and at 3, we have points on the graph on the x-axis. All right, let's talk about the y-intercepts now. All right, for the y-intercept, you set x equal to 0. So we'll have 0 plus 2, 0 minus 3, 0 minus 1, and 0 plus 1. And of course, that's going to give you negative 6 in the numerator and just negative 1 in the denominator, which gives you a total of 6. So at 1, 2, 3, 4, 5, 6, in other words, right here, we have a y-intercept. Since we have our y-intercept there, let's extend this axis a little bit further. So we'll give another couple points here just so we have a few more places on the graph. Okay. Then from there, let's go ahead and locate the asymptotes. First asymptote we're going to look at is the vertical asymptotes. Those will occur when the denominator is equal to 0, so x minus 1 is equal to 0, and x plus 1 equals to 0. So that'll be x is equal to 1, and x is equal to negative 1. Those are the two places where we'll end up getting undefined points in the function, so I'm going to draw basically dotted red lines there. So the graph will not run into these asymptotes. Remember, it's not possible to cross the vertical asymptotes. However, we might be able to cross the horizontal asymptote. So let's look at the horizontal asymptote then. Since the degree of the numerator and the denominator of the function are the same, x squared over x squared basically for the leading terms, it's the ratio of the leading coefficients. This is going to be 1 over 1, or in other words, 1. So at y equals 1, we have a horizontal asymptote. Okay, now let's see if the function can actually cross that asymptote or rely on the asymptote if there's any points on the function equal to that. So let's start with our original function, x squared minus x minus 6 over x squared minus 1, and set it equal to y equal to 1, or set it equal to 1 in other words. Well, if we cross multiply there, we'll have x squared minus x minus 6 is equal to just x squared minus 1, right? In other words, we're multiplying this denominator times that 1. Then the x squareds here can certainly cancel out, and you end up with negative x minus 6 is equal to negative 1. So then it'll be negative x is equal to minus 1 plus 6, or in other words, negative x is equal to positive 5, or in other words, x is equal to negative 5. So we do have a location on the graph where the graph is equal to the horizontal asymptote, where x is equal to negative 5. So we're going to have a point at negative 5 on the x-axis, and y is equal to 1. So we'll have a point right there. All right, very good. From here, the rest of this is just plotting points to see what's going on around these intercepts and asymptotes. So let's start with some points that are real close to both the intercepts and the asymptotes. So I might want to know what's going on, for example, at negative 3. I think that's good. Actually, let's go all the way from the far left. Let's actually put in negative 9 just to see what's going on there. Then we'll put in, let's say, negative 3, want to know what's happening around there, right? Then we're going to look at maybe the value 1.5 on the negative end, so negative 3 halves or negative 1.5, right? Then I might be interested in what's happening at negative 1/2, right? And then perhaps at 1/2 on the positive side of the number line. Then I'd certainly be interested in what's happening at 3 halves or 1.5, right? And then from there, we might be interested in things like, for example, I don't know, let's say 9, positive 9. We'll go all the way out to the extreme on the positive end. So there's just a handful of points. These points will probably tell us a lot about the shape of the graph. And from here, I'm just going to use basically the arithmetic to work out these values, but I'm not going to show that on the screen. It's just too tedious, right? So, okay, let's plot these now. Negative 9, you get 1.05. So all the way at negative 9, you just get a little tiny bit above this horizontal asymptote, right? At -3, you're at basically 3/4. So maybe about there. At -1.5, you're at -1.8. So you're talking about something right here. So it looks like the curve is kind of dropping down below there. At -1/2, you get to 7, right? So at -1/2, we're going all the way up to 7. So about here, right? And then at +1/2, you're at 8.3. So maybe that's about right here or so, right? Then at 1.5 or 3/2 on the positive x-axis, you're down at -4.2. So here's -4, so maybe 4.2 is somewhere around there. And then at 9, you're at 0.83, all the way out to 9. You're only at 0.83, you're not even at 1. And you know you'll never get to 1 on that side because we do not have a point on that asymptote, right? All right, so it looks like the graph is hugging this asymptote here, coming up, and then hugs the other asymptote and goes on and on forever in that direction. Then on the left side, it looks like it does a similar thing. It's kind of hugging the asymptote, but it does cross. But then it really slows its growth, and then of course shooting down after that, probably hugging that asymptote because we know it can't cross that line. And then of course up here, it's a little bit peculiar here. We could probably plot a few more points, but from experience, I bet that this is doing something like this here, right? So it's going to probably hug this asymptote all the way up. So you have almost like a little mini parabola there. And that's basically a good sketch of the graph to give you a rough idea of what it looks like.